All right, we're going to do basically the same thing we did in the previous one. We're going to try to get the most stable conformation of two stereoisomers, and I need to make sure that I keep those two ethyl groups cis and trans. So cis, I want two methyls either pointing up, both of them, or down, both of them. In trans, one of them is going to be up and the other one's going to be down. The other thing that you need to watch out for is the position of your ethyls, because sometimes we're so going for everything equatorial, we don't even notice that we need to have the substituents on the right carbons. All right, so right here I'm going to go ahead and I'm going to do a chair for each. You should always practice drawing your chairs. I'm going to, with a pencil, which I had a pencil somewhere. There it is, I found it. I'm going to mark my axial and equatorial positions on carbons 1 and carbons 3. So you may not even be able to see the pencil, but this is carbon 1 right here, one up, one down, and this is carbon 3. I do that just to make sure that I'm doing this right. All right. I need to put two ethyls, and I need to make sure that I put them cis to each other. So either I put them both on the up position or both on the down position. Now, since I actually want the most stable one, remember that the more substituents you have on equatorial positions, the better. And that's important right here because the down positions on carbons 1 and 3 are both equatorials. So it would be in our best interest, to put those two ethyls on those down positions, because that way they would both be equatorial. If you want to go ahead and put them both axial, you're going to have to flip the chair. All right, those are cis, down, down. This is a very nice and stable chair conformation for the cis 1,3 diethyl. If I was to flip the chair, if you flip the chair, they would be both axials, and I know that's not going to be the most stable chair. All right, in terms of the trans, when you have trans, remember one goes up, the other one goes down. I'm going to move this up again. So I'm going to put one up and the other one down. It doesn't really matter because one of them, as you can see, is going to be on an axial position. The other one, to be trans, have to be in a down position. And if I was to flip this chair or interconvert the chair, this one would go equatorial and this one would go axial. So I would still have one axial and one equatorial. So when you flip the chair, you notice that both chairs have the same energy. So for the trans, I have two chairs of the same energy, and for the cis, I have one chair, which is the most stable one, because both substituents are going to be on equatorial positions. Now between cis and trans, which one is the most stable stereoisomer? The cis, again, because in that chair, I was able to put two substituents on equatorial positions.